Hi everybody. Today we have a Eventek KPS305D power supply. So I bought this a few years ago off of eBay. It's relatively unlabeled, but historically I've never had a power supply. I've always used ATX computer power supplies that were modified, or linear regulators on breadboards, or wall warts that you would just plug in. And a couple years ago, I got tired of it. So I said, you know what? I'm going to spend 50 bucks, buy an El Cheapo Chinese power supply because it's better than nothing. I didn't expect great things. Then I started noticing sometimes it seems like I might be getting noise from this when I'm performing measurements, especially some of the audio equipment work that I've been doing. I don't even recall what the actual ratings on this power supply are. It says 0 to 30 volts, 0 to 5 amps, 30 times 5, 150 watts. For the weight of this thing and $50, I highly question if it could put out 30 volts at 5 amps, but who am I to say? It's just analog adjustments and your typical power switch and screw terminal connections here. So my thought is I'm going to open this thing up. I'm thinking maybe there's just a really cheap switch mode power supply in here that's actually putting out some EMI or polluting my AC lines. I don't have a good line filter on my lab bench here, if you want to call it that. So let's open this thing up and see what it looks like. Okay, getting the last screw here. It looks like this lid should just pop right off. Maybe. Oh, yep, here we come. Okay. So just metal lid. You know, nothing fancy there. Inside and outside is painted. Wow. Alright, right off the bat, I'm actually blown away by the quality that I see here. I expected this to be a very cheap looking board. The fact that there's 4 sets of magnetics on here, multiple capacitors in parallel, it's already not bargain basement. So looking at this, we'll just start from the incoming IEC power jack on the back here, which also has a fuse in it. It looks like the ground they bring immediately to the board on this screw, which goes all the way through to this 1/8 inch aluminum plate. So that whole plate's at ground then, which in turn is connected to the chassis, so the entire chassis here is also connected to ground. So it goes through the front panel switch, comes into the board here. Let's see if we can get a little closer for you guys here. It looks like coming in, I would guess that this was an MOV, but actually it says NTC, so negative temperature coefficient. That's typically used for inrush limiting. So it will limit the amount of inrush power to these capacitors, and as it warms up, it stops limiting the power. So it just helps to prevent a sudden surge when you first turn it on. This is a X capacitor here. It's most likely across line and neutral. Then we have a common mode choke here. Decently sized. Sometimes these are really undersized. We have 2 small, I don't know if they're actually Y rated, but I'm assuming those capacitors are to ground. And another X capacitor. That is a pretty typical EMC filter. When you look at a flyback, transformer, etc., computer power supply, you're going to see the same type of setup. I would say these components are decently sized for the size of supply. I didn't expect that. I really thought that this part would be non-existent or very cheap. They have 2 Bulk capacitors in parallel there. It looks like, you know what, it could be parallel or series depending on your voltage switch. You can look it up. There's a fancy way of using that. You'll see it in ATX power supplies for computers everywhere. We got a fan, decent thickness fan, so it's really quiet. You hardly notice the fan running, but it seems like it could move a decent amount of air, so that's nice. We see on the top of the board here 3 transistors, although if I was a guessing man, I might actually say probably 2 transistors and a diode. Oh, interesting. Q3 to Q1, so 3 transistors. In fact, this one has a dual footprint. It can be a T220 or a T247. So I wonder if they have a larger version of this, that they just put a bigger FET in there, or BJT, whatever it is, that can have larger power dissipation. And those 3 are dissipating heat into this large aluminum backplate here. I'm really surprised by all the magnetics here. I don't know if this is a flyback transformer. Typically 100-watt supplies in this range, you'll use a flyback. But then I also see extra magnetics out here as well. And this is I'm guessing an isolator. Let's see if we can see what this is here. There's a TNY 277. That's probably a feedback isolator to give yourself AC isolation. I guess it's possible these could be used as gate drive transformers or something to isolate your drive signals. I see a small U1 there. I don't have the correct lighting to read what it is here. Actually, let me give it a try under a light here. It looks like we got a LM358. I believe that's an op amp. I would actually have to look up what that is, though. That might be a power management IC, but I don't think so. I see a lot of small discrete transistors in here, which almost makes me wonder if this is some sort of a self-resonant system that drives that primary transformer. Judging by the size of this is probably about 40 millimeters long. This is sized to be 50 to 100 watts, depending on your frequency and the quality of that transformer build. Honestly, when I purchased this, I kind of assumed, like a lot of the cheap Chinese ones, that this would actually be a linear regulated supply, but I don't see anything that points to a linear regulator here, unless they're using some of these transistors up here, but I'm assuming that those are driving on the high voltage side, this big guy. I see a couple of capacitors here, most likely output filtering. We have some high quality aluminum polymer caps, it looks like, on the board, so that's not exactly cheap either. I'm, in general, very surprised by the quality we see here. Large inductor. So this makes me think definitely not linearly regulated. Most likely we are stepping something down to probably an intermediate voltage rail, and then possibly we have a buck converter that's being driven by some of the ICs on this front face board, and setting the voltage based on analog inputs and a current limit as well. These 2 copper things here, you'll see those in multimeters. Those are typically low ohm, high current resistors. They're basically copper, and you just rely on them to be close enough to, 10 milliohms or some arbitrary value that they designed the circuitry for. Yeah, in general, very surprised. And actually, the back panel, well, the face panel has a lot of stuff going on it here too. Hard to get a great camera shot all in focus at the same time. One thing that immediately stands out is I see these potentiometers up here. I know that my display is not super accurate. If I want to get an exact voltage or current, I'll put a series and parallel multimeter on the output just so I can tune it, especially if I'm trying to measure efficiencies or something. There's probably 5% error on that voltage readout screen. I would be curious here if these are actually trim pots to adjust that. And I see two more trim pots down here. One is labeled V and one is labeled A. So it's actually possible that maybe those are the adjustments. I think I have enough space I could turn this on and turn those and see what happens. So why don't we do that here? I'm going to zoom back out a little bit. Back to 1x. Obviously be very careful. You either have a half well, it looks like a full bridge rectifier there. So 180 or close to 300 volts inside this chassis. So let's plug it in carefully, not electrocute ourselves. Turn the supply on. Okay, we saw the fan kick in. Interesting. So the fan must actually only run based on some thermal feedback, which explains why this supply is so quiet. So here I'm seeing 14 volts. Let me get out a multimeter here and let's see what my multimeter actually says this is reading. Put this guy here. Let's make our life mildly easier. Oh, you know what actually? Here. It came with these not super high quality set of alligator clips. But for this, they will work great. I just don't have another banana jack immediately available. So I'm just going to put these clips on here. And then we will just clip it to the standard multimeter leads. This is very low quality PVC insulation. It is not very flexible. So let's clip this on here. And I'll try and spin it here to get some of these connections out of the way once we get to that point. Okay. So we can, we can read the multimeter. Let's flip this guy on. Oh, there we go. Helps if we plug it in all the way. Very interesting. Helps if we also clip it on. Okay, now we're in business. Interesting. Okay, those are pretty close. Typically, if I'm running 24 volts, I have to have this set under. It is fairly cold in my basement today, though. I'm wondering if we have some temperature sensibility. This is really just about on. So I'm going to see if we adjust this trim pot here carefully. I'm just going to pick one of the two to adjust. Okay. Looks like nothing happened. Let's pick the second one. The screwdriver is a little big to engage these trim pots very easily. Needs a little bit of help here. Okay, come on. Okay. Spin the second trim pot. Interesting. I don't see the screen readout change at all either. It's possible if part of the power supply controls on that board, that could be something to do with the actual raw like intermediate bus voltage or whatever. There's the second set of potentiometers here. I'm going to try twisting and seeing what happens. These are not as controllable. Oh. Yeah, we need a smaller screwdriver for that. Let me see what is immediately available. Oh, you know what? This guy might work. I'm just trying to be real careful not to accidentally touch anything in there. Oh, yep, okay. So now here's the magic question. Does this also affect... Interesting. So it affects both the display and the output. So that would make me question then if this is actually a 0 point for the coarse versus the fine voltage. So I'm going to turn both of these down and let's see what it'll go down to. Almost nothing. Okay. Let's crank this guy up. Interesting. So, we got that. Okay. Apparently I have a LED light bulb that is on the fritz. I'm going to turn this off. Let's try just putting a load. This is just 200 ohm resistors in parallel. This might require some creative connecting here. Alright, so now we have a parallel meter, we have a series meter. Let's just try and set it to 190. You know, again, we are spot on today. And I've definitely noticed in the past this is not spot on. So I'm not sure where the discrepancy is, but I don't think I'm even going to try and make any adjustments. The display is really matching those multimeters well. Pretty happy with that. In general, for $50, this power supply operates fairly well. Now, I suppose it's possible if I really crank this up under load, potentially these become less accurate. We can try that momentarily. I don't want to put a whole ton of power through these because they're sitting on the table without a heatsink. But we can, for a short period of time here, just crank these up and let's see what we get to. So at maximum of 30 volts... yeah, that's pretty close still. 0.58, 0.58, it matches well. Current limit kicks it out pretty fast. Now this is something that always has bothered me, is the current limit goes way below 0. Way below 0. You have to turn this up quite a bit. Probably about 20-30 degrees before you start getting current limiting. So this is a case where I would question, is that adjustable with this screw? Because that would be nice to have a little bit more dynamic range here. Ooh, okay. That actually made it worse. So I'm going to crank this up. Oh. It's not really much better. No. Not a whole lot better. Okay, I'm going to turn this guy off. We're going to unplug it before we get electrocuted. Just unscrew these two things quickly here. So there we go. In general, for $50 from the factory, pretty good quality. Now, being Chinese, I don't know if you bought another one of these a year later, if it would still be the same. My guess is it's going to have slightly different innards. But pretty happy with my purchase upon review here. I don't like buying cheap stuff, but sometimes it works out. Alright, I think I'm going to close this guy back up, and that's all we got for now. So thanks for watching, everybody. Yeah, if you have one of these, hopefully it works as well for you as it seems like it's been working for me. Hey everyone. Just a continuation of the Eventek review here. While I had everything out, I thought, you know what? I might as well at least see, or at least give you guys an idea of what the turn on step looks like, and if there is any noise visible on the oscilloscope, in case some of you guys maybe don't have oscilloscope equipment, and you're wondering what the quality is here. I've done this historically and it's pretty good. So I have a 10x probe. All the information on the screen is correct. First, I'm just going to turn this on. Sorry, we're on AC coupling here. Okay. I'm going to set the supply to about 12 volts. And we just saw it's actually pretty accurate. So it's a 1/4 amp current. Okay. I'm going to set just a 2.5 volt rise thing there. I'm going to guess that this supply is going to comfortably come up in 1 millisecond per division should be fine. Like, I would expect 10 milliseconds. You know, let's start at 2. We can always zoom in. Find out what that edge rate is here. So we're going to do that. We will do a normal single trigger. Trigger is rising, channel 1. Yeah, we'll leave it at 20 megahertz bandwidth limit. That's fine. That'll just get rid of some noise. So let's see what happens here. Oh, actually, it's even a softer startup than I expected. That's kind of nice because that means we're not going to have to worry about over voltage situations. Some of these cheap supplies without soft starts, you'll get some voltage spikes and ringing, especially if you have longer cables. We don't have very long cables. We have probably about 2 feet of cabling, and it's not a huge current, but you can get that inductive spike if you have a rapid rising edge. So let's just try this again here. Oh, okay. It looks like we do have a little bit of a peak. If I throw some cursors on this guy, and let's try and zoom in on the scope here, since this is primarily what we're going to be looking at. That's pretty good. Yes, you should be able to read all of that. Yeah, you know what, we can get even in. We can get that in even a little tighter. Okay. So I'm gonna throw. We have X and Y cursors on here. We're gonna look at. So it looks like X. We are adjusting X1. So I'm just gonna look at and see what is this edge rise time from. I'm just gonna estimate 10 to 80% here. Looks like about 30 milliseconds is like a 20-80% time. So for the system to actually stabilize, it looks to be something a lot closer to, from initial power on, I'm going to say about 50 milliseconds to stabilize. And we're set to about 12 volts steady state. So if we go back to our cursor here, that Y1 is set to 0 volts. Y2, if I go to the tip top of that, it looks like we peak at about 12.7. And if we bring back down to steady state, just judging kind of by the edge of my scope trace there, it's about 12.0. So that is like a 5% overshoot or something. Not bad. Again, $50 supply. Not bad at all. I'm going to turn it off just because we are... they're not even warm, hardly. So that was pretty good. Next, let's set this to an AC coupling. I'm going to turn the cursors off here. I'm also going to clear all of our measurements. And cursor off, measure, statistics. Let's just start this guy up. We'll set it to auto. I'm going to just step on in here till we get to 100 millivolts per division. Okay. We'll leave it at 100 millivolts per division. If I step in to a higher frequency here, let's see if I can get it to trigger a little cleaner. 50 millivolts per division. You know, it's single. Okay. So I don't know if that is switching noise coming from this or not. I guess the way to tell is let's just turn it off and set it to auto. Okay. Quiet when it's off. So that is probably that internal buck converter or whatever the switching control mechanism is we talked through. So let's just single this guy. Let's get a good one where we can see a shift here. So like what you're seeing right there, where you have a dampening out ringing and then that step shift, that's definitely a switching edge. I think I see another switching edge right there if I step out one more. I'm just trying to get a single where we can see a couple of those really nice. I'm going to guesstimate what the switching frequency is here. In fact, well, first we can measure what that ringing is. It's not insignificant. That's about 100 volt peak-to-peak ringing. If I turn measures on, let's see what is it telling me here. We have about 90 volt peak-to-peak. Frequency-wise, oh, it's looking like that's only 100 kilohertz ringing. That's a lot lower frequency than I expected. I'm just going to verify that that is really what it is with the cursors here. And I'm looking at this high frequency ringing here. Well, compared to the period. So I'm just going to set one cursor there. That tip top. And this doesn't have to be perfect. Okay. So that is about 600 kilohertz. 600 kilohertz ringing at 100 millivolt peak to, or 100 millivolt peak to peak that's going to give off a little bit of noise. Possibly some of the measurements I'm doing, that's actually what I'm seeing is that noise there. Although at 12 volts, you can't complain too much. Now, if we step back out, if I had to guesstimate, you know what? Here, the nice thing about this scope is you can zoom. So I'm going to find where we have one of those clear edge transitions. I think I see one right about here. Let me go to Y, set Y1 right there. Then I'm going to scroll over till I find another edge transition. It's either right here. Could be here. That would put us at about 100 kilohertz resonant frequency. Actually, you know what? I'm off on the first one, aren't I? How did that happen? Interesting. Oh, okay. There we go. Scroll back over here. Again, doesn't have to be perfect. I probably don't even have to zoom in to see that. Oh, 77 kilohertz. So I would guess that probably is the actual switching frequency of the buck converter or whatever's in there. For power electronics that size, historically it used to be closer to 20 kilohertz, but nowadays 40 to 100 kilohertz is not crazy, especially if this is the offline switching noise that we're getting. Offline flybacks and stuff for this size of supply, if you were to design one today, you'd be somewhere between 50 to maybe 200 kilohertz. The frequency is slowly edging its way up over time, but so there's some switching noise there, but not bad. It's in the 100 kilohertz region. So depending on what you're doing, if this is plugged into an audio system, you'll never hear it. It's above audible frequencies. But it's not beautiful. Again though, $50, pretty decent. If you really wanted to knock that out because you're trying to do a low-level measurement, you could always on a breadboard put a linear regulator past this, especially like an adjustable one, and it would help cut that probably by at least 20 dB, 30 dB most likely. Again, really surprised with the quality of this supply. Really surprised. So I think that kind of completes, you know, if we want to, we can jump it up here slowly. I am AC coupled, but it still jumps it quite a bit when you move this up. I'm just curious, as we increase that voltage, does our noise go up? Interestingly enough, it might actually be going down. Oh, 96 volts peak to peak. Okay, so we're about the same amount of noise, even though we doubled the load. Yeah, so even under half an amp load, which again the supply can do 5 amps, but half an amp load at 30 volts, so 15 watts, it's It's not great. It's not terrible. Pretty good for a lot of use cases. So to summarize, pretty pleased with the quality of this supply. Again, $50, didn't expect much. I don't like buying cheap stuff, but I did. And it panned out really well. The amount of noise that's here for a lot of amateur use cases, even if you're doing some audio stuff with this system, you're not going to hear it. You're not going to see it. It's pretty decent quality. Even under a 15 watt load, the noise didn't seem to shift between like 5 watts and 15. Now maybe as you edge up to like a 50 watt load, that might change, but really pleasantly surprised by the build quality of this. Inherently, it seems pretty safe. I didn't look at how well the flyback system there was isolated, but judging by the EMC filtering and stuff, it seems like someone put some amount of design and cost into this. It's not the cheapest supply that you can possibly get. So with that, everyone have a good night, and thanks for watching.